Hi guys, first of all, great show, really love to listen to you. However, on design patterns you sometimes make it a lot more complicated than it actually is. With the risk, running the risk of you finding me very cocky or annoying, I would like to explain a little bit about these design patterns that you mentioned in the last show. First of all, the command pattern. That you started on, the command pattern, what it allows is that you can create a queue of commands that you execute on an object, the so-called receiver. And that queue also has the option to undo and redo commands. To be able to implement that, the command itself needs to maintain the state of the receiver before it changed it, and be able to make the changes, and then on undo, a colon undo, use that state or part of the state that it has of that receiver to restore the state. So when you look at the example over here, I have a div element with some text, which is my receiver. I then have a command, a change background color command. I click that and it changes the background color. But when we look at this command, over here, that's the style command. Excuse me. So I take the previous value of the style, and then on undo, I set the current style to the previous value of the style. So in the execute of my style command, I take the previous value, I store that, and then I make changes to the style property of the div element. On undo, I simply reset the property of the style property of the receiver back to its previous value. Okay, we store that in a queue inside the invoker. Yeah, and the invoker has the execute command. What this allows me to do is I can actually change the alignment as well, and the background color alignment, something like this. I can do all sorts of stuff. And all it does is that it creates a queue with commands that know the value of the style attribute of the receiver before they were executed, so they can actually undo it and set it back. Let's click the undo over here, and you'll notice that all the actions, the commands that were executed before, are now reversed. You mentioned the memento pattern, and that can actually be used very well within commands. It depends, however, on how large the state is of your receiver. So in my case, I use the style element only, so it's a lot easier for me to just, attribute, so to just store the current value of the style attribute. But if you would allow, for example, to make changes within the text, like delete the text or make it bold or italic, and you are going to add elements, HTML elements to the text, it might be difficult to store the exact HTML changes in the text. Okay. What then would be a lot easier is, instead of storing the changes, just before you execute the command, store the complete inner HTML. We store that complete inner HTML, and then we make changes to the HTML. Then whenever we need to undo the command, we can simply restore the complete inner HTML. And in this case, the complete inner HTML, and of course we also have the style attribute, but that's something else, but the complete state can also be stored by using the memento pattern. So the memento pattern stores the complete state of an object in two methods, the get memento and set memento, and the get memento returns an object that is the state of the memento object. So we get a memento, which is the current state of the object. Of course, we could do that and use that pattern over here. So when we execute our command, we first set that this previous value equals receiver get memento. So we have the memento object. And then when we undo, we just set this receiver dot set memento and pass in the memento we received earlier. So in that way, we can combine the command pattern with the memento pattern. You mentioned like that's a lot like the observer and button clicks. It's definitely not the case. A button click is an observer, and the object being observed, which is the subject, is not busy with who is observing him. He will just notify every object. And it also has nothing to do, the command pattern, with buttons in a game and registering buttons in a game. Because that will be a completely different pattern. That's a very well-known pattern. It's the state pattern. What does the state pattern allow you? The state pattern allows you to put an object in a specific state. So you mentioned a game, so I'll keep the example of a game over here. Let's say you have a game character, and a game character can walk, ride, and swim. And depending on the state the character is in, is he walking, is he riding, or is he swimming, the buttons will have to do something completely else. So when I click on the A, B, X or Y button while I'm walking, something else will have to happen than when I click the A, B, X and Y buttons while I'm riding. And it's not the character or the object of the character in memory that is actually sending out button clicks, and then the click event handlers will determine like which state is the object in right now. Because imagine that you're walking and you're jumping. At that moment you have a state of mid-air walking, and you have the same thing with a car, and also while swimming. Well, it's so your button clicks would get so complicated because you have to check so many items, and the switch statements of these button clicks would be like switch object current state. Then the state might be walking, running, walking, jumping, walking, crawling, walking, I don't know, something else. Swimming fast, swimming slow, swimming underwater, swimming on top of the water. It might be driving fast, braking, driving in a curve. And I would have to do all sorts of checks in my button click to indeed allow for the correct action to happen. The other problem is that as soon as a new state arrives, so if our game now involves climbing and we create a new state, we have to go through all of our button clicks and then add a new switch statement to indeed involve climbing and all the states that you have within climbing. So you have the state pattern, and what the state pattern does, you place the object in your game, a character, in a specific state, and the button click is not handled by the object, but by the state. And that state knows everything about himself, so it doesn't have to think like, okay, what is the state? Because it knows I'm the state. And I have an example over here on a music player, and here's the code. A music player state, you all know music players somewhere they always have a start button, a stop button, and a pause button. So any music player state will have a start action, a stop action, and a pause action. So whenever I'm in what state I am, when you hit the start button, that action will be called. When you hit the stop button, that action will be called. And when you hit the pause button, the pause action will be called. We then have a defined stop state, a concrete stop state. Whenever I'm in the stop state and I click the start button, I will first of all start playing and then change the state to started state. When I hit the stop button, while I'm in the stop state, I will just notice, yes, sorry, but I'm already stopped. I will not do anything. When I hit the pause button, this pause action on the stop state will be called, which says, sorry, I cannot pause because I'm not started. But when I hit the start button, I will continue and change the state of the player to started state. When I'm in a started state, I have these three buttons again, the start button, the stop button, and the pause button. When I'm in the started state and hit the start button, I just say I'm already started. When I'm in the stop state, I will stop playing and then move back to the stopped state. Okay? And it's the same for the pause state, that when you hit start, I will continue playing. When you hit stop, I will stop. And when I hit pause again, I just lock, sorry, but I'm already paused. Then here we have the music player. And what it will do, it always has a state. And it starts, in this case, in the stop state. And then whenever I press a button, I don't have any click handlers over here and do anything smart over here. No, I just forward the start button press to the current state. And that allows me to, when I have a music player over here, I have a new music player. When I hit stop, it says I'm already stopped. When I then hit start, I start playing. When I hit start again, because the state has changed from stopped to started, or playing, I continue with, sorry, but I'm already started. When I then hit pause, I change the state to pause. When I then hit start again, I say continue playing. When I hit stop, I of course stop to play, and I'm back at my starting stage, which is the stopped state. So that's the state pattern. So in games with assigning buttons to actions, you do definitely not have a large switch statement that based on the current state will figure out what to do. No, you will have a state pattern implemented, something different. Then we have the mediator pattern, and you guys mentioned like, yeah, sorry, but it's the same like an observer, and I think it's not. There's a very big difference. When we look at the observer, you will notice that we have observers that are interested in anything that happens to the subject. Okay, so they are not interested in each other in any way. They are just interested in the subject. And the subject also does not make any distinction between any of the observers. So whenever something happens, it will automatically call all observers, does not make any distinctions, no business logic. It will call all observers and then call update on the observers. So the observers are interested in the subject and completely not in each other, and the subject does not contain any logic on who it will call to notify of the update. Let's look at the mediator pattern. The mediator pattern is actually the other way around. We have a mediator and we have some colleagues. These colleagues are absolutely not interested in the mediator. No, they are interested in each other. And you gave a perfectly fine example on the flight coordinator. Okay, so whenever somebody enters the airspace that belongs to that flight operator, they will just call in. They tell them, I'm here. Okay, they are at that moment not interested in the flight operator. No, they are just letting him know, I'm here. Then, whenever something happens to one of the airplanes that are in the same zone as I am, I want to get a notification from the mediator telling me that what I have to do. So I am only interested in the other airplanes that surround me. The mediator has a task of making sure that I will only receive the messages that I'm interested in. And it can do multiple things to do so. There might be reasons for a mediator if two objects cannot even talk to each other. When we go back to the flight operator example, one of the airplanes might have a digital radio and the other airplane might have an analog radio. They are still interested in each other. They want to communicate with each other, but they will not communicate directly with each other. No, if somebody has to say something, he will get in contact with the flight operator, and then the flight operator will make a decision like, okay, for whom is this message important? And it will then connect with that object, with that plane, in the way that plane likes to get in contact with or is able to communicate with the flight operator, and it will then notify him, and only those planes that have an interest in that action or in that message, that something has happened. So there might be a protocol transition, there might be, for example, other logic in there. But the mediator definitely does contain business logic to validate and make a choice, like who am I going to mediate this message to and how am I going to do that. The example that you see on chat rooms, I have an example of that as well. They should make a change in a standard chat room in a way that you do not want your message to be received by everybody within the chat room, but only a specific set within the chat room. So I have an example over here. I have myself, and I'm an adult, and I have my colleague, who's also supposed to be an adult, and I have my son over here, who's not an adult, and I have my nephew, who's also not an adult. Now, all these chats, they communicate with the mediator, the chat room, and the mediator has a business rule, a very sensible business rule, that conversations between adults should not be forwarded to children, and the other way around, that conversations of children should not be forwarded to the adults. So what happens over here when I send a message, hi there, it will know that I am an adult, and when I click send, it will verify, okay, who are the other adults around here, and it will only forward my message to those adults. So when I click send, you will notice that Norbert received the message, hi there, but of course these kids did not receive the message because they are not interested in messages from adults. The same with kids. My son, he's Dutch, so when my son as a child sends out a message, I as an adult am completely not interested in all sorts of messages about SpongeBob and a new episode of it. So whenever a child sends out a message, the mediator, the chat room mediator, will only forward that message to Rens because he is also a child and he might be interested. And that is an example of a chat room where the mediator pattern definitely applies. Then I would like to have a short start on the repository pattern and the unit of work. The unit of work is so when we look at entity framework, for example, first of all, you mentioned that, you want to do an abstraction because entity framework is connecting to SQL Server. That is actually wrong. The entity framework is a mapping tool which allows you to connect not only to SQL Server but also to Oracle. And the good part with entity framework is that it does the mapping. If you look at the XML that's being produced within the entity framework, if you don't use the code first, actually contains 3 levels. It's the database level, it's the object level, and then the mapping level. Just open the how you call this, EDMX file. Just open it with an XML editor, and you will notice that there indeed are these 3 sections: the database level, the object level, and the mapping level. And the database level can definitely be changed. So you already have a abstraction over there. So there is no real need for the repository pattern. However, a lot of people are used to that repository pattern, and there are some good things about the repository pattern, so I can imagine that you do want to use it. Do, however, know that you will also lose a lot of the performance and the goodness of the entity framework, because the entity framework is already a repository pattern. It just returns iQueryable. But with the iQueryable, I can still make my nice selections and update the items and stuff. But so entity framework is already like a mapping tool. And it is already an abstraction of my database, and it does allow me to make a connection to an Oracle database. So that's not a reason to create the repository pattern. Then go back to the unit of work. So you mentioned the unit of work. The funny thing is that the entity framework, DB context, actually implements unit of work pattern. Because what is the unit of work pattern? The unit of work pattern says that it should track any changes made to a database, and when you want to actually execute that unit of work, it should only forward the changes and the changed objects and the deletions to the backend and not all the complete objects and anything else. It's a way of making sure that you will only forward changes and not complete objects, but also making sure that you execute them in the correct order. Entity framework, however, with the entities and change tracking, already fully implements the unit of work. The only reason that when you create a repository, that you're creating a unit of work again, is because you might want to use the entity framework with a repository pattern in a web application type of web application. In a web application, you will have a request start and a request end. If you do use the repository pattern, and if you, depends on the way you do dependency injection and stuff, if you would actually create a new repository object, and the repository is always created with its own version of the DB context, you broke the unit of work part of the entity framework, because you create a new database context for every repository, and if you have a customer repository, it will have its DB context. If you have a orders repository, it will have its own DB context, and then when you want to hit save changes, you will have to call save changes on both these repositories that will both update their own database context and will both update their changes. So the reason why you want to re-implement the unit of work that you dropped out of Entity Framework when you included the repository is that you want to align these repositories. And what you can then do, for example, is create a DB context on the request of the page, on the start, on the initial phase, and then in the end, and you pass that DB context to all these repositories. And then in the end request, that's where you call DB context save changes again. And then you are again reusing the unit of work pattern that is already there in the entity framework. I think that's all for what I want to mention right now. I hope it does make sense, or it clears things up a little bit. You guys have a really great show, but on the design pattern, sometimes you are making it very complex. Enjoy, guys. Bye-bye.